Number 1 from today's bell work asks, is 36x squared minus 24x plus 16 a perfect square trinomial? So reminding ourselves what a perfect square trinomial is, that is a trinomial that comes from multiplying two binomials that are exactly the same by each other, so the same thing by itself. Just like 2 squared gives us 4, and 4 is a perfect square. So a perfect square trinomial would come from something like x plus 4 times x plus 4. The result would have to be from multiplying the same thing by itself, and sometimes you can see it written as just that binomial squared. Those produce perfect square trinomials. So we're going to check and see if that's the case by factoring this trinomial. Before I jump into factoring, I always want to look and see if there is a GCF, if there's a factor I can take out of all three terms and simplify this a little bit. So we've got 36, 24, 16. At a minimum, they're all even numbers. We can at least take out a 2. So I've got 36 divisible by 4, 24 is divisible by 4, and so is 16. So I believe the highest number we can take out, the highest factor, is a 4. So if I take out a 4, I am left inside with 9x squared minus 6x plus 4. Alright, so now we're trying to see if 9x squared minus 6x plus 4 came from a perfect square trinomial. So at this point, my number out front, my leading coefficient in front of x squared, is greater than 1. So we've learned more than one method of how to factor this. We did previously learn how to slide, multiply, factor, divide bottoms up. On Friday, we did some guess and check methods where we really just played with the numbers to see if we could make it work. Okay, so this 4 is going to stay outside, and that's part of my final answer, but I'm not considering it anymore while I'm trying to see if these two terms were the same. So I'm going to do the guess and check method again, just because some of us were really uncomfortable with it. So guess and check method, instead of doing slide, divide, bottoms up, I've got to consider that this 9 came from two numbers multiplied. I know it's x squared, so it was at least an x and an x. So I'm going to think of some factors of 9 that could have been multiplied. Well, it's either 3 and 3 or 9 and 1. I'm going to try 3 and 3 first, because truly, if it's a perfect square trinomial, these have to be the same. So I'm trying to see if it really is 1. Okay, my other options I have to focus on is this 4 at the end. I need to see what are the factors of 4. So my options are 2 times 2 or 4 times 1. Again, I'm trying to see if this is a perfect square, so I'm going to see if the 2 times 2 works. Okay, the fact that this is a positive 4 tells me that the 2's must have been the same sign, but the fact that the 6 in the middle is negative leads me to believe that maybe both the 2's needed to be negative, because a negative 2 times a negative 2 would give me a positive 4. So the only thing left to do, I've made it to where they match. I need to FOIL this back out and see if it produces this trinomial. So remembering FOIL, I've got first times first, so 3x times 3x gives me 9x squared. The outer two terms, 3x times a negative 2, will give me a negative 6x. Then the inner two terms, negative 2 times 3x, will also give me a negative 6x. And then the last two terms, negative 2 times negative 2, will give me a positive 4. So the beginning and the end worked, but the middle term did not work out, because a negative 6x minus 6x had to be a negative 12x. So because of this reason, this cannot be a perfect square trinomial. It is not working out to give us this original trinomial. And so even though I have other options of factoring, that's not the question. The question is this a perfect square trinomial? If I use these other options, these will not produce the same binomial multiplied by itself. Therefore, the answer should be no. All right, question number 2 says the area of a rectangle is 20x squared minus 27x minus 8. The length is 4x plus 1. What is the width? Well, we know to find the area of a rectangle, you do length times width. We've already got one dimension, we're going to have to factor to find the other. So before I start factoring, I always want to look at these terms, see if there's a GCF to pull out. I've got 20, 27, and 8. I don't believe there's a number that goes evenly into all three of them aside from 1, so there's nothing to take out. So now I've got to determine how I'm going to approach this problem. If I didn't have one of the factors already, I would need to determine how I'm going to factor this. Do I want to slide, divide bottoms up? Do I want to guess and check? What's my method? Well, I'm going to utilize this one term they've already provided me with and see if I can kind of guess and check what the other term must be. So one of the factors is 4x plus 1, and we're just trying to figure out what does that have to be multiplied by to give us this trinomial. So in order to get a 20x squared, 4x had to be multiplied by a 5x, so we know that much. In order to get a negative 8, though, there could be a couple combinations. So to get a negative 8, originally we could have had 4 times 2 and 1 times 8. Well, this term right here is what's going to be multiplied by this term to give us this result. Well, this is already a positive 1, so negative 8 divided by positive 1 means it must have been multiplied by a negative 8. So we've worked it out, but now we need to make sure that matches this middle term. So we're going to fold it back out and see if that worked out. So we had 4x times 5x, which is 20x squared. Outer two terms, negative 8 times a positive 4 is going to give us a negative 32x. Inner two terms, 1 times 5x is going to give us a positive 5x. And last two terms, 1 times negative 8 is going to give us a negative 8. So combining like terms, negative 32 plus 5 does indeed provide us with a negative 27x in the middle. So that comes out to be the original. So if the length is 4x plus 1, the width must be 5x minus 8. So you could have taken it the hard route here, worked it all out, but it was smarter to use what they already provided.